Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Stephen Feuerstein and I'm a PL/SQL developer, just like you. This lesson is part of my series on Say Goodbye to Hard Codings, and the topic of this particular lesson is dealing with magic values, the simplest form of hard coding, but an important one to address. Some quick reminders. If you haven't already done so, visit my PL/SQL Obsession site at toadworld.com/sf. You can download all the code and PowerPoint documents that support this lesson. So any of the files that I demonstrate during this lesson are available in my demo zip download. So go to PL/SQL Obsession, click on Companion Files for Training, and you can have access to all the files that I use in my presentation. Make sure you're comfortable with the material covered in the previous lessons in this series, and that is, at this point, just one: overall introduction and concepts around hard coding, single point of definition, the importance of naming things and information hiding, the opposite of hard coding, soft coding and easy coding. So make sure you've got those under your belt, they make sense to you, and then proceed. Dealing with magic values. Here's the agenda. I'll just do a quick review of what a magic value is. Then I'll talk about hiding magic values behind constants, hiding them behind functions, and we'll look at the differences between those two, the trade-offs. Then we'll take a look at soft coding these values into tables, the most dynamic approach of all. I'll touch on how you should hide error codes with the exception init pragma. And a little interesting idea for using silly values for your magic values. And that'll be it. So, magic values, essentially literals. What do we mean by this? Well, a magic value is some sort of value, whether it's a string, a number, a date, that has some special significance in your application that is often treated as a constant. In other words, it's not going to change. It's always going to be like this. For example, the maximum salary allowed for employees is 1 million. This is an example of a rule that has within it a hard-coded literal value. And it's sometimes really, really hard to avoid the temptation of writing that code, that value directly in our code. For example, I'm writing my process employee procedure, and if the salary is greater than 1 million, it must be the CEO. Well, here's a violation of the rule, but in any case, the same example, the same idea. 1 million is a hard-coded rule. In this case, what I'm saying is that if you make more than $1 million, you must be the CEO. In any case, we tend to fix on these values as if it's some sort of psychological crutch. Everything's changing around me. Nothing's stable. Maybe this value will not change. I can anchor myself to that value. So I make an assumption that it will stay the same. Of course, that assumption is bad. The value changes. So this is the most commonly recognized form of hard coding. Generally speaking, if you ask a developer to find the hard codings in a program, they will immediately fix on those literal values. And as I talk about in my previous lesson on introduction and concept, this is just one of many, but it's certainly an important one to get rid of. The only place the literal, the actual value, should appear in your application is in its single point of definition, the place in which that actual value is defined and given a name and then referenced. And the way you do this generally is to hide your literals behind constants or functions. You can also consider soft coding the values in tables. We'll look at all of these things. So, hide behind a constant. Instead of exposing the literal value and referencing it in multiple places, you declare a single constant, which means you give it a name, assign to that constant the value, and then reference that name. The best place to put such constants is in a package specification so that your entire application code base can reference the constants. These are really simple and quick to do, but there are some downsides. First of all, let's look at the example, then we can come back and talk about the downside. Why get all negative right away? So in my package, in my file called constant versus function, here's an example of an exposed literal value. Take a case of the order status. When it's open, then fill the order. When it's closed, then close the order. So I have these hard-coded literal values appearing in my application and quite likely appearing in multiple places. I don't want to do that. Here's an alternative. What I can do is create a package. It's called the app configuration package right here. And I create two constants. I assign the default value to be open and closed. And then in my code I can say, well, do a case on the order status. when it's equal to appconfig_package.copen, appconfig_package.closed, then I can execute the correct command. But notice, the actual value is hidden away. You as a developer don't need to know the specific value, and you don't want to hard code it because it's likely to change. So there's an example of using a constant to hide these values, and I'm just going to do a quick edit while I'm here to prepare for the next phase, which is to use functions instead. So let's just clean that up a little bit. Okay, so again, my application configuration package, one or more constants. I reference those constants by name. The literal value disappears. If I ever have to change the value, maybe I'm going to change it to open order and closed order because we decide that that's clearer to understand when we look at the values in the table or something like that. I change it in one place, and then all my code, the rest of my code, does not have to be modified. Great technique, and it's simple and quick to do. Here's the problem though. They expose the value in the package specification. So in other words, if I have execute authority on the package, I don't own the package, but I can execute it, then I can look at the constant, I can see the value. And that means also that if the value has to change, then every program that's dependent on this package will have to be recompiled. It will be forced to invalid state and recompiled. So basically you're exposing the dependency of the value into all these different programs, even though I've hidden the actual value with a name. If the value changes, this code is rendered invalid. And the other problem is I expose the value, which means somebody might get lazy and decide to use the value anyway. So let's take a look at an alternative, which is to hide values behind functions. Instead of having a constant in my package specification, I could create a function that returns the value. It's given a name just like the constant name, but the value is hidden inside the package body. That means that when the value changes, only the package body has to be recompiled, which means that all the programs that are dependent on the package do not have to be recompiled. They're not forced to invalid. That can be a big advantage when you've got a large body of code all referencing the constant, and you've got a lot of developers working on that code and not wanting to have it forced to invalid and recompiled. And certainly in production, it's an even bigger issue. The other advantage over constants is that the developers cannot see the value. In other words, I might define a constant for copen and declare it to be that value, but there's no way to force you to use it. You could say, oh, I don't feel like typing all that application config package.copen. Obviously the value is just open. It's not going to change. So why make my life more complicated? I'll just put it right there. So that's the other danger of using a constant. Everybody can see the value, even if they can't change it, but they can certainly get lazy and use it, which you really don't want people to do. So the alternative is to create a package that has within it functions. So I have an open status function, I have a closed status function. And inside my package body, I declare constants and assign the values to them, and my functions simply return the constants. Now, the resulting code doesn't really look much different. Let's show you what the code would look like with these magic values in place. So appconfig package, open status, and closed status. So they look pretty much the same. In fact, you might want to include an open and closed paren to indicate that they are function calls. You might not. In any case, the value is hidden away. And if I don't own the package, if I just have execute authority on the package, then all I can see is the package specification. I can't see the package body. I can't see the values. I can't get lazy and replace the value with quote open end quote. So it builds an additional level of security and improves the chance that the code will be reused. And again, if I change the value in my package body and recompile, code like this does not need to be recompiled because it hasn't been invalidated, because the package specification hasn't changed. So that's a nice advantage over constants. The downside of using a function is that it's less efficient than a constant. Let's take a look. So I've created my package that has the constant in it, that has the functions in it. And in fact, I'm going to do a final version of this package that has both that we can use for testing. So let's create this package again. I'm going to take the two constants and add them to my package as well. Right here. Clearly, you generally don't want to do this. Either you have them inside the function or you have them exposed in the package spec. But what I'm going to do is use this package definition to compare the performance of querying, of using a constant and using a function. So I'm using my SF timer package, which is part of your demo zip, and I can calculate elapsed time down to the 100th of a second. So I start my timer. I'm going to execute this code 10 million times, show the elapsed time, and then do it again for my function. And I can see the performance of a constant versus a function. And when I run this code, we'll just ignore all this other stuff. It should take about 3 or 4 seconds. I see the following results. The public constant took less than 100th of a second, 10 million calls, less than 100th of a second. When I put it inside a function, it took 3.3 seconds. Now, obviously, on an absolute basis, that's much, much slower than less than 100th of a second. So clearly, just referencing a constant and not calling a function is more efficient. However, this is 10 million iterations. The per function overhead is very, very small. So I think that when you make the decision about whether to use a constant or a function, you should not be worried about the performance unless you're working in a situation where you have to worry about every single 100th of a second. Most of us do not. The performance overhead of calling a function, while significant compared to a constant, on a per function call basis is tiny. So you have to balance off the advantages, which is you're hiding the value, you're minimizing recompilation. Developers can't easily see and use the value, but you lose a little bit of efficiency. Now you could get even fancier, more dynamic, and soft code values in a table. So rather than putting the values in a constant, whether they're in the package specification or in a function itself, you can put them in a table. You could associate them with a name and retrieve them as needed from the table. What are the downsides of this approach? Well, it's a more complex configuration generally because you've got this table, you have to maintain the table, etc. There's more overhead because you're querying the data out of a table rather than accessing it in your package directly. But using caching, especially the function result cache of 11G, can really avoid a lot of that problem. Let's take a look. So I'm going to create a table called magic values. It has a name, an identifier, the name of the variable that I might use in my code, the actual magic value, and the data type of the value. Now this is a very simple version of this kind of package. You could get really fancy. You could have separate columns for each data type, a magic value date, a magic value string, a magic value number. You could even use the any data type and have a single column that can store all the different types. So this is basically just a prototype to give you an idea of what's possible. I inserted several different magic values. Maximum salary is 1,000,000, it's a number. Company name, Oracle Corporation, it's a string. Earliest date allowed in my system, October 11th, 2000. And it's type date. So I can declare these different, I can document these different magic values in my table. And then there are a couple of ways I can use the data. First of all, I could have a generic function. Get me the magic value for the specified name. So every time I need the value, I have to hard code the name. I have to specify earliest date, company name, maximum salary. So there's still some hard coding going on there, but the name is a general description of the value. It's unlikely to change, though it could, in which case, assuming it doesn't change, I can simply look up the magic value and return it. Whoops, and return it. Let's add that return. So this would give me one function returning any of the magic values. I just specify the name. And of course there is overhead calling the select statement compared to calling a function or a constant. It's much, much slower. But in Oracle 11G I can add the result cache keyword, and then it would only perform the query the first time that anybody asked for the value for a specific name. So that's a nice way to get the maximum flexibility of a soft-coded value. If my value changes, I just change a value in a table. No code has to be recompiled. And I also get the performance benefits of not having to run the query every time. Alternatively, I can take the values in my magic values table and I can generate a package and reference the constants or functions in the package. And what you see here, the gen magic values package does exactly that. It queries the data from the table. It generates a package, and then we'll write it out to file or to screen. Let's try it out. So I'll create the table, populate it, create my function, and then create my package. So here's the code that was actually generated. It creates a function for the identifier name, returning whatever type of data is specified, and then it returns the value, or it sets the value and returns it inside the package body. Notice it automatically does the to-date conversion because it's a date specifier, etc., etc. So you have a variety of alternative approaches. Even within a magic value approach, you can have a single lookup function. You can generate a package, in which case, of course, the package has to be regenerated every time there's a change made to the table. But either way, this gives you much more flexibility even than hard coding all these values in a single package like this and having to maintain it yourself. So it all depends to some extent on how fancy you want to get, how much of an infrastructure you're going to set up for your applications. Using silly values for constants. Now sometimes when you're using magic values, you get to decide the value. For example, with status codes, 0 is success, 1 is failure, -1 is runtime error, who knows? You get to set the values. Now often we do use reasonable values, like success equals 0, failure equals 1. The problem with using values like this is that people will be tempted to cheat and reference the value directly. So what you might want to consider doing is using silly values instead. What you're doing is essentially making it embarrassing for anybody to ever consider using your literal value in the code explicitly. Here's an example. When Oracle 9.2 was released, Oracle added a lot of new features into the util file package. You can remove a file, you can copy a file, you can see if a file exists. And in general, if something goes wrong, they raise exceptions, like file does not exist when I try to remove it. I decided to offer an alternative, which is to return status codes. So call the fremove procedure mine, and it returns a status code instead of raising an exception. So for example, success, file not found, file not removable, etc. And I could have said status is 0, file not found is -1, file not removable is -2. But then people could be tempted to write things like call my fremove procedure, and then if status equals -1, then. And I really don't want people to do that. So what I do instead is declare my constants with really crazy, silly values, like this. Now, I think it's pretty unlikely that anybody's ever going to write something like that in their code. It's just too embarrassing. What the heck is that number? It's doubtful that you'll ever run into the need to do this, but it's something you might want to keep in mind. Finally, hide error codes with exception init. Oracle doesn't provide names for all the errors that they define. For example, no data found is a named exception, which I just showed you an example of under soft coding literals. When no data found, then return null. No data found is a named exception that Oracle created for us in the standard package. The error number is actually, well, 100 or -1403, but we don't want to say or hard code when others, then if SQL code equals -1403, then you really don't want to do that. You don't want to hard code any kind of error codes. So that's why Oracle gives us names for the most common exceptions. But there are many that don't have names. That's okay. You can create names yourself for your exceptions by using the pragma exception init. What you don't want to do is ever write code that hard codes references to error code numbers. It's not that the error code's ever going to change. I'm sure Oracle won't do that to us. The problem is that people looking at the code have to understand what the heck it is that you're talking about, and that's what you don't want. So whenever you need to reference an error code by number, there's no name for it, declare an exception, use the pragma exception init to associate that named exception with the error number, and then inside your exception section, you can reference that error by name instead of by number. A very simple technique, again, for hiding the implementation, the actual value behind a name, but in this case for an exception. And again, best place to do that is to put it in your packages, package specifications, so that you only have to declare such exceptions once. For example, in my error package, a very simple prototype of an error management package, I declare my failure and for all associated with -24381, and then I can reference that when I'm using for all with save exceptions. Conclusions. Magic value hard coding is by far the most commonly occurring and recognized form of hard coding. We all know we shouldn't do it. We all do it anyway. It's also the easiest to remove from your code. So use constants or functions to hide the value. Define that value in a single place. The differences between constants and functions are good to know about, but the most important thing is that you have a single point of definition where you hide that value and only reference it by value once. And of course, you can get fancier and put the values into tables and expose them either as constants, as functions, or provide a generic lookup function by name. Next steps. Download that demo zip file. Try out the various scripts that I showed you. Consider using that soft coding of literal values into your table, and make sure that you're comfortable with all the different aspects that are raised in this lesson. And then watch the other lessons on how to remove various kinds of hard coding from your programs. Magic values are the simplest and the easiest to deal with. We'll take a look at how to avoid hard coding SQL, how to avoid hard coding algorithmic mechanics, how you're getting the job done, and so on. I hope this lesson was helpful to you, and best of luck in your PL/SQL coding onwards. Take care, everybody.